For the first part of this problem, we're being asked to determine the roots in simplest a plus bi form of this equation. Well, the fact that it's asking us to give it in a plus bi form is a bit of a giveaway that we're going to be needing to use the quadratic formula. But to start, let's move all of this over to the left-hand side of the equation. So then we'll have x squared minus 6x plus 17 is equal to 0. All right, so we're going to be using the quadratic formula to help us out here. So our b value is negative 6. So negative b, or negative 6, would become positive 6, plus or minus negative 6 squared minus 4 times our a value, which is just 1, times our c value of 17. And then that's all going to be over 2a, which is 1. The next thing we want to do is simplify what's inside the radical there. So if we took negative 6 squared, which is 36, minus 4 times 1 times 17, that actually gets us root of negative 32. And that's all over 2. All right, now the next step we're going to want to do is take a look at this root negative 32 and simplify it. Now the first important thing to note is that we can factor out a perfect square of 16 out of this. So we can think of this as the same thing as root 16 multiplied by the square root of negative 2. Because of course, the square root of 16 we can figure out as 4. Now the square root of negative 2, we want to think of that as the square root of the square root of 2 multiplied by the square root of negative 1. And we're doing that because, of course, the square root of negative 1 is equal to I. So combining all of these together, the square root of negative 32 is the same thing as 4I root 2. So moving back to the equation we had over here, we can now rewrite this as 6 plus or minus 4I root 2 all over 2. And as our very last step, we can actually divide both that 6 and 4 by 2, so that we would have 3 plus or minus 2I root 2. And we're finished. For the last part of the question, it says to consider the system of equations below. You'll notice that both of these match the left and right side of the equation above. And it says that the graph of this system confirms the solution from part A is imaginary and explain why. Well, when you solve a system of equations, graphically what you're doing is you're looking for their points of intersection, where these two graphs would intersect. So the fact that the solution is imaginary, well, that means that they don't intersect. So to answer the question, we can state that when graphed, the two equations never intersect. This means there are no real solutions, which confirms that the roots from part A are imaginary. All right, hope that was helpful, and that's all for this video. Thanks for visiting JD's Preparation.